Good day to everyone. I am Prince Ashvik Sabil. To continue our report, I will be discussing the charging by induction, the charging of two-sphere system using a negatively charged object, and also the positively charged object. And lastly, the law of conservation of charge. For the first part, charging by induction. It is a process of charging an object without making any direct contact between the object and the charging source. It works by bringing a charged object near a neutral object, which causes a redistribution of charges within the neutral object. This redistribution results in one end of the neutral object becoming positively charged and the other end becoming negatively charged. So the movement of electrons leave an imbalance of charge on opposite sides of the neutral conductor. While the overall object is neutral, there is an excess of positive charge on one side of the object and an excess of negative charge on the opposite side of the object. The charged object used to induce a charge in the neutral object is usually a charged rod or a charged balloon. When the charged object is brought close to the neutral object, it repels electrons within the neutral object, causing them to move to the opposite end of the object. The end of the neutral object closest to the charged object becomes oppositely charged, while the end farthest far from the charged object becomes like charge. This separation of charge can be used to create an electric current or to store electric charge in a capacitor. Once the charged object is removed, the neutral object will retain its induced charge for a short period of time, allowing it to be used for various applications. Charging by induction is a common phenomenon used in many electrical devices, such as transformers, electric motors, and generators. It is also used in everyday objects, such as static electricity, created by rubbing a balloon against your hair. Next, we will discuss about the charging of two-sphere system using a negatively charged object. If you have a two-sphere system and want to charge it using a negatively charged object, you can follow these steps. First, bring the negatively charged object close to the first sphere. So, for the first image on your left, you will see that this will cause electrons in the first sphere to repel and move away from the negatively charged object. Second, since electrons are negatively charged, they will move to the second sphere, which is now closer to the first sphere than the negatively charged object. As a result, the second sphere will become negatively charged. Then, once the two spheres have acquired opposite charges, they will likely attract they will likely to attract each other. These will cause electrons to flow from the second sphere to the first sphere until the two spheres reach the same potential. Then you can then remove the negatively charged object and the two spheres will now have equal and opposite charges. It's important to note that the amount of charge transferred to the spheres will depend on the size and distance between the spheres, as well as the charge of the negatively charged object. Then, after which, we'll have the charging of two-sphere system using a positively charged object. So, same thing, if you have two-sphere system and want to change it using a positively charged, uh, katong ganina, negatively charged man to, so karon, we'll have the positively charged object. So just follow these steps. Bring the positively charged object close to the first sphere. This will cause electrons in the first sphere to be attracted towards the positively charged object. Next, as a result of the attraction, electrons will move from the first sphere to the positively charged object, leaving the first sphere with a net positive charge. Third, since electrons have been removed from the first sphere, the second sphere will have an excess of electrons relative to protons, giving it a net negative charge. Then, once the two spheres have acquired opposite charges, they will attract each other. These will cause electrons to flow from the second sphere to the first sphere until the two spheres reach the same potential. After which, you can then remove the positively charged object and the two spheres will now have equal and opposite charges. It's important to note that the amount of charge transferred to the spheres will depend on the size and distance between the spheres, as well as the charge of the positively charged object. The force between two charged objects is proportional to the product of their charges and inversely proportional to the square of the distance between them. The charges on the spheres can be calculated using Coulomb's law, which is this one. Next slide, we will discuss about the law of conservation of charge. The law of conservation of charge is a fundamental principle in physics that states that the total electric charge in a closed system remains constant over time. In other words, electric charge can neither be created nor destroyed. It can only be transferred from one object to another or redistributed within an object. This law is based on the observation that in any process involving the transfer or redistribution of electric charge, the total charge before and after the process is always the same. For example, if an object gains a certain amount of positive charge, it means that the same amount of negative charge must have been transferred to another object or distributed elsewhere in the system. The law of conservation of charge is a consequence of the more general principle of conservation of energy, which states that energy can be created or nor destroyed, only transformed from one form to another. Since electric charge is a form of energy, it is subject to the same conservation principle. So that's it for my part, guys, and I will give the screen to the another presenter. Thank you and have a blessed day ahead.